Here we're going to be talking about scatterplots and lines of best fit. A scatterplot is a graph that represents a relation between two variables. Right, a relation, remember we talked about a relation versus a function. A relation is just a set of ordered pairs. So it's really just a set of ordered pairs on a graph, and it's relating two variables. Usually it's going to be an x and a y. They can change the letters, but it's really talking about the relation between two variables on a coordinate plane using the x and the y. A correlation measures the strength of that relationship. It's a number that represents the strength of the relationship. Strength of the relationship. So we have a bunch of different types of correlations, and they all correspond with different graphs. So we have really three different types and then different degrees of a correlation. So the different types are positive, negative, and none. And those go perfectly along with slope. This has a positive slope. This has a negative slope. This does not seem to have a slope at all. They're just scattered everywhere. They're random. There is no correlation that goes along with this x and y. Then we also have different degrees of correlation. So it can be either none still, that has a very weak, that's the weakest it can be. It could have a low correlation or a weak correlation. It could have a high correlation or a strong correlation. And then it could have a perfect correlation, which is the strongest correlation. All three of these are positive. But some of them stick to that line better. Actually, I'm drawing lines of best fit in there to show you, really just to mark the trend of the points. They're all positive, so they all match up with a positive slope. But the first one, the blue one, is weakest. The middle one is stronger because they're closer to that line. They line up more with our line of best fit. And the purple or pink one lines up perfectly with our line of best fit. That's the strongest correlation that we can have. So we can have different strengths of the correlation, those are degrees of correlation, and we can have different types. It could be positive, negative, or just none, where they're scattered. We're going to actually find the equation of these lines of best fits, and that is all using the calculator. So you could try to find it by hand, but it would really just be an estimate. The calculator can find exactly the line of best fit using what's called a linear regression. Basically finds the average middle point for all of these points that are scattered on the graph. It finds the middle of those points. So we're going to use the calculator for all of this. If you ever need to come back to this video, please use that. The first thing I want you to do is just clear the memory. Hit second, memory, second the plus sign, then 7, then enter, then 2. So that clears our RAM so that we don't have anything in there. Now we're going to go to our list 1 and list 2 by pressing stat. We're going to hit the stat button. That brings this up. Then we hit enter, and that brings up all of our lists. Now we're going to list the x values in list 1 and the y values in list 2. So from this, I'm using my left column as my x, my right column as my y, the time as my x, the time spent, the minutes spent studying is my x, the score on the test is my y. I'm going to put those into list 1 and list 2. Oops. I got my x values, now I got my y values. So I have all of my x's and y's in there. Make sure it matches up. Make sure those coordinates go together, and make sure there's the right number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Being sloppy here basically makes the entire problem wrong, so you need to make sure that you're getting this part right. There's 10 numbers there, and actually you can see it in the calculator. Right there, you can see that it says list 2 has 10 elements. So that means I did that right at least. Now, I'm just going to look at the scatter plot on the graph right now. So I want to just see this on my graph. Right now, if I hit graph, it's not going to work. I need to hit second and y equals, second, blue one, and then y equals. That brings up this list. That's the stat plots. And I want to just turn this first one on. So right now I got into plot 1. I have to turn it on. I have that highlighted. Make sure it looks exactly like that. Your list 1 and list 2 should be your x and your y. Now I should be ready to graph, but again, if I just graph it there, it's not zoomed into the right stuff. So I have to hit zoom, and then the number 9, number 9 is zoom stat. That's zooming into whatever statistics I put in there. You hit 9, and that gives you the graph. That's our scatter plot. So this has a positive correlation. That's going uphill. So if I'm describing the relationship, the type is positive. And they're pretty well connected with that line. They're not perfectly along that line, but they're pretty well connected on that line. I would say this is a fairly strong positive correlation. Okay, now we're actually going to find the exact line of best fit. We don't want to just estimate what it is. We want to find the exact equation of the line. So, a line of best fit. First off, it describes the relationship between the two variables. This equation will describe it perfectly. It's written in slope-intercept form, which means it's going to look like this: y equals mx plus b. And it can be used to make predictions about the data. That's the most important use of this. From the data that we have, we can make predictions about stuff that we actually didn't measure. We can figure out stuff that we don't know based on the equation that we have. So we're going to use the calculator to do this. And like I said before, we're going to use a linear regression. So we can have our list entered into list 1 and 2. We already did that, so we don't really need to do that again. We're going to use that linear regression to find our line of best fit. So we're going to hit the stat button again. Then you go over to calc, and you see that fourth option that says lin reg. That stands for linear regression. And it's showing you the equation that it's going to give us. It shows it a little bit different than our y equals mx plus b. This is really our m. The b didn't change. So we're going to hit enter there. The default list should be list 1 and list 2. But if you enter stuff into other lists, you still need to know how to type this in. So we're going to type in list 1 and list 2. I'm going to type it like you see here, list 1 comma list 2. If you have a different calculator, it might not show up this way. It might show up with this screen, in which case list 1 and list 2 should already be there, but I still want to show you how to type those. You can see it on the calculator. There's an L1 and an L2, and they're both in blue. That means we have to hit the second key before we hit that. We hit second and list 1. Of course, that didn't work. Second and list 1. Then you have to hit the comma that's right next to the parentheses. And now second and list 2. Now you can hit enter. That gives us the equation, or at least it gives us the numbers for the equation. Our slope is the A. Like I said before, A really is the same thing as M. I'm going to round that to the hundreds place. I'm going to say that's 0.57. And my V, or y-intercept, is this 48.03. I'm actually just going to call that 48.0. So my equation is y equals mx plus b, y equals 0.57x plus 48.0. That's the equation that splits right through, so that's what you can see here, splits directly through those points. On average, it's as middle as it gets. We actually want to see that on the line, or sorry, on our graph. So we're going to go to y equals and type that equation 0.57x plus 48. And then you can hit graph. And it's still zoomed into the same stuff. So there you go. That's your line of best fit.